RACE is UKA's Centre for Remote Applications in Challenging Environments. We design, maintain and operate robotics in the extremest of environments. This is really pertinent to our mission, which is to put fusion energy on the grid. When we start to think about electrical design for future fusion power plants, this is going to be delivered globally and collaboratively. Integrating electrical design between multiple companies, multiple users, having a platform that can be scaled is really important for the delivery and efficiency of that. So we've been operating SOLIDWORKS for around about 7 years at UKA, and I think we're around about 70 or 80 projects delivered to date. UKA has its own PDM software that has been bespokely created for the operation of JET, the Joint European Torus. We've built upon that, and what's really key is the technical requirements, so creating technical files and revision control of all them documents which electrical drawings through design into manufacture into operation will need to go through that system for revision control.
So our Ultimate One Boom system is made up of over 1,200 cores that traverse about 50 meters to 80 meters of cabling on the plant. It's split into 3 major systems. You've got the control cubicles at one end, the wiring in the middle, and then the end effector at the end, which is Mascot. Mascot's our flagship manipulator. It's an old 1950 design mechanically, but electrically it's evolved quite a lot in that time, and we now are digitizing it for the modern era, and the plan is to have a first-of-a-kind digital version of Mascot on the end of the boom for 2025 and 2026. So the drawings produced basically covered all of the cabling and wiring in the cubicles from end to end. There's over 1,000 pages just in the boom wiring alone. The 1,200 cores is over something like 80 meters of length. There's 9 breakpoints where there's connector sets in the middle. And all of this was drawn in SOLIDWORKS Electrical, starting from single line drawings and working down to the low level schematics. In terms of the drawings, it's very difficult to get all of that into one project because it's just so massive. It would, I think we tried it once and it would break the server. So we had to split it into smaller projects. So every part of the subsystem has its own project in SOLIDWORKS. Each project has its own set of books. Each book has its own set of reports. So it's quite logical. Every set of schematics looks the same in terms of its structure. And we start with a single line drawing, and then we go through the schematics, and then we go further down into the bill of materials, the generated reports and that kind of thing. So for this particular project, because of the sheer number of cores and conductors, probably the automated checking of duplicates, so the duplicate marks, the duplicate wire numbers were probably the best ones to have that check rule completed for. Having a human physically check 1,200 cores in terms of unique identifiers is nearly impossible. So doing that with SOLIDWORKS Electrical was a really quick and easy process, and it really helped us speed up our review process. And so we use the standard templates for things like bill of materials, standard features like wire lists and cable lists, but we created our own macros and used SOLIDWORKS tools to create connector lists and connector tables. Those tables were really useful for us because we could use them basically to see all of the connectivity of a plant on one bit of paper, and then you can reference that from different sheets and you can click to different parts of the subsystem as well. So yeah, really useful. The design initially was done in sort of 2019, 2020, went through manufacture. So the review and approval process took something like 3 to 6 months. At that point in time, we were on SOLIDWORKS 2019, a lot of the checks were manual. So in the latest iteration, a lot of the checks have been automated, and it's been massively reduced down to something like 1 to 2 months to get everything reviewed and approved from a blank set of unreviewed drawings to a completely released set for manufacture. So when you generate the PDFs from SOLIDWORKS, you have clickable items in the schematics, which allows you to click through to components, to specific wires, to specific pages. That was really helpful. So for a system that has over 1,000 pages, you don't want to be scrolling through and trying to find each sheet. So you want to be able to click an arrow, find the sheet you need to go to, click on a component on a single line, it pulls you into the schematic and takes you there. Click on it again, it takes you to the bill of materials. So really, really useful, really quick, and it saves a lot of scrolling.
We do our integration by using the built-in integration tool provided by SOLIDWORKS. So we create our 2D schematics using SOLIDWORKS Electrical, and then we link it to the 3D parts which are available in our 3D models assembly. So the advantages we have is we are able to reduce our errors and then generate bill of materials, create cable and wiring routing. It also helps us make sure or compare our design electrically to the mechanical design. We sometimes use physical inspection and then also red lines from the manufacturing team. So once they are done with the as-built, we receive red line markups and then we update on the 3D model. So it helps us have an accurate 3D model of what has been built. We use annotated views and then red lines from as-built. We document that and then we send that into the site installation team. So once they're able to compare what has been received as built and then the document, we then use that as our sign-off document.
We use custom reports primarily to check against the standards we are using. It is mainly formatting, layouts, ensuring rigorous standards that we keep are maintained. Every single component has to be unique. Every single wire has to be a unique ident as well, and every single wire has to have a specific format. SOLIDWORKS allows us to check all of those details through custom reports. We use SOLIDWORKS custom reports. We use a number of them straight out of the box. There are a number of reports that work straight away. Unique ident by component, unique ident by wire, but there are a number that don't. So we have developed our own custom reports, which are generated through the SQL server side of things, custom SQL reports, and they do drill down into drawing format, layout template, as well as specific formatting for specific marks that we work with.
I think the biggest lessons learned is creating the right environment, so the input data that you're embedding within the software. This is really important for consistency of output of drawing sets. So when you have 30 different designers all delivering across multiple projects, it's really key for efficiency to have the drawings being delivered in a similar fashion, and that's really key.